Today we will discuss about a simple supported beam with uniformly varying load. From the picture we are seeing that A and B point of a beam is simply supported, and above the beam there is a uniformly varying load which is maximum value of W at the A point and minimum value of 0 at the B point. Now we have to calculate reaction forces of both end and shear force diagram and bending moment diagram. First of all, we have to find out the reaction forces A and B, taking the moment about A, and here we may write down RB into L equals to downward moment. At first we have to find out the average load per unit length. How do you calculate that? And W is the maximum and 0 is minimum. So W plus 0 by 2 equals to average load, that is W by 2. W by 2 per unit length. So the total weight W by 2 into L, WL by 2, that is. To find out downward moments, we know that downward loads into CG distance, that is WL by 2, and the CG distance 1/3 of L or L by 3. So as per equation we may write down RB into L is equal to WL by 2 into L by 3. So RB equals to WL by 6. And now I have to calculate RA. We know that RA plus RB is equal to total load. Total load means WL by 2. Total load is equal to WL by 2 and RA is equal to WL by 2 minus RB WL by 6, and RA equals to WL by 3. As per diagram rule, at the B point the shear force value is WL by 6. So the diagram will start from the positive side of B from the point WL by 6, and it's just go down towards the RA because of downward load. It will go up to that value, that is WL by 2, total downward load, and again it will touch the RA line and towards a negative value WL by 3, and total diagram will form a parabolic curve. Now we will find out the bending moment at the point B. As we taken the moment about A, so distance for bending moment at the point B will be 0. So the bending moment also will be 0 at the point B. And now we will find the bending moment of point A, and at the point where shear force diagram changes its sign, for that point we will find out bending moment at the last. For the calculation of bending moment at the point A, RB into distance L, RB equals to WL by 6, WL by 6 into L minus WL by 2 into L by 3 equals to also will be 0. So bending moment at point A equals to 0. Now we have to find out the bending moment at that point where shear force changes its sign. We taken the distance from end B to that point is equals to x. Now we will find out the value of x subject to L. Considering that point as M, the shear force will be equal to reaction force WL by 6, as the upward force by RB is equal to WL by 6 will be equals to the downward force by the UVL. If for L distance the maximum load is W, then for X distance the maximum load will be W by L into X or Wx by L at the M point maximum load, and so on. The average load will be Wx by L by 2, and the total load up to point M will be equals to Wx by 2L. Wx by 2L into X equals to Wx square by 2L. I previously told that Wx square by 2L will be equals to WL by 6, and from there we may get X is equal to L by root 3 or 0.577 L. Now at the point M, the bending moment will be RB into X minus Wx by L into X by 2 into the distance from CG to the M point M equals to X by 3. Now we have to put the value of X, that is L by root 3. We will get from that equation that bending moment at the point M will be WL square by 9 root 3.